Okay, in this case we're going to talk about suspension and suspension rate. The principal function of the suspension is the vertical flexibility on the tires to perform in every highway, maintain the tires in the correct direction with the steering also, support the vehicle's weight, and maintain the contact with the wheel with the floor every moment. That's the principal one. In this case, we're going to compare two kind of suspension. One is McPherson and the other one is Sherlock arm suspension or SLA, and both are independent suspension. The McPherson, this is the way it looks, and it is commonly used in modern cars. And there is a kind with strut. This is a strut. That is the pre-compressing of the spring. That the advantages of that is the more space, the loads are better distributed, but we have other disadvantages. That is small values of anti-dive and lead and a little design flexibility. And the other one is the short long arm, and this is how it looks. Some of the advantages is the large amount of design flexibility and the long travel that this one has. The disadvantages is that you need to assemble more parts, and that means more weight.
Hi, my name is Jose Luis Pargonal. I am explaining the concept of the spring rate. So, what is the spring rate? In automotive, the spring rate or suspension rate is a component setting in the vehicle ride height or its location in the suspension stroke. But in math, the spring rate is a rate used to measure how a spring is to begin span or compression during the spring deflection. So, how calculate the spring rate in automotive? Well, the spring rate is calculated with the next equation: C equal to wheel rate divided motion ratio elevate to square multiplied by the angle of correction factor. So, how calculate the wheel rate? Well, first, the wheel rate is another concept. The wheel rate is actually the effective spring or spring rate when the measure it the wheel at rate. So, how calculate? We calculate the wheel rate with the next equation: the suspension frequency in hertz divided the sprung weight. So, the motion ratio is calculated with the dimension of the suspension. So, dimension A divided dimension B. And the angle of correction factor is calculated with the difference between the dimension A and the suspension. So with this concept we can calculate now the spring rate.
The ride rate is the change of wheel load at the center of tire contact per unit vertical displacement of the sprung mass relative to the ground at a specific load. In other words, is the vertical force per unit vertical displacement of tire ground contact point relative to chassis. Here have some examples in a SLA suspension and a McPherson suspension. In the SLA suspension, when the force is applied, the whole suspension is going to move vertically. This displacement is known as ride rate. As you can see, it can be upwards or downwards. Now we have a McPherson suspension. As in the SLA suspension, when the force is applied, the red arrows, the system will have a vertical displacement, and this is the ride rate. The displacement depends on the force, so if the force is bigger, the displacement is going to increase.
The wheel rate is the effective spring rate when measured at the wheel. This means that it is the effective stiffness comparison between the front axle and the rear axle of the vehicle. Basically, it is the spring rate, but instead of measuring the linkage of the arms, we're measuring from the wheel. There are several ways to calculate the wheel rate. One of them is using this formula, which uses the square of the suspension frequency divided by a factor of 187.8 times the sprung weight. We can also calculate the wheel rate with a concept named motion ratio, which is the ratio of the displacement of the point of interest to that of another point. With this, we can calculate the wheel rate with the square root of the motion ratio times the spring rate. Therefore, the units for the wheel rate are in pounds per square or newton per millimeter. With this, it is important to remark that the wheelbase rate is different under braking and accelerating conditions than cornering conditions.
Hey, my name is Jonathan and I'm gonna explain you a little bit about the tire rate. Here we have an example of the code of a tire. So let's begin. First we have the load index that is specified by the manufacturer with the maximum of load rating that the tire can have. With a higher load index, you can increase the load of the capacity. In this case, we have an 87, so we can have a 1,201 pounds in this tire. Then we have the speed rating, that is this letter of our code, and this represents the high speed you can reach with this tire. And in this case we have an S, so we can reach up to 180 kilometers per hour for a family sedan and vans. So then we have the rim diameter, that this is the size of the tire. A lot of sedans have like in this case the 15 diameter in inches. Then we have the construction of the tire, that it's the way they construct the tire, and it can be built, diagonal, radial, and cross-ply tire. This is how they look, and in this case we have a radial one. And then we have the aspect ratio, that is the relation between the height and the width of the tire, represented as a percentage. We have a 60, so we can see that this is the way it looks. With a higher number, we can have a circle form of the wheel. The nominal width, it's just the width represented in millimeters. In this case, we have a 195 millimeters in this part of the tire. And finally, the tire type, we have here different kinds of tires for all season, for winter, for performance. But in this case, this represents if this tire is for a passenger car, for a light truck, for a special trailer, or it's for temporary use.